is very essential in case of power house. Now, let us see another auxiliary, that is power line carrier communication. It is a very important and very interesting. The term power line carrier is used to represent the entire process of communication which uses high voltage overhead power lines by means of transmission. Such equipment is used for communication, relaying, telemetering or for supervisory control. So, I can explain in details, you can see here figure. Here is a one station, here is the TPS, here is the HPS. Hydro is the HPS is a hydroelectric power plant, the thermal power plant. Suppose I want to communicate to TPS immediately, then I want to use communication. So, distance from this station to this station is above 400 kilometers. I cannot use the wireless communication. If I use the PNT phone, that is the BSNL, the line may be busy, then how I can intimate to the power operators? Here is I can use already existing power line. You can see a figure. The tower carries the power lines RYB3 lines. These lines use as a communication lines with the carrier frequencies. These frequencies are generally above 30 kilohertz to 500 kilohertz frequencies. And by using some electron circuits, we can communicate from one station to another station. There is a possibility of interrupt this communication, the frequencies, carrier frequency to power transformer. So, that purpose we use the line trap or wave trap. It avoids entering of the carrier frequencies. Here use this is known as a CVT, capacitor, tuner, some coil. Similarly, here also we used. And you can see the figure how is now the power is continuously flowing from one station to another station. Then I want to communicate this station to this station. You can see figure how it is carrier communication going on. Same frequencies used. Now, I communicated from this station. It is a continuous process. Without affecting our power system, we can use the power line as a telephone line or communication line. Next, so another auxiliary, so that is exciter and pilot exciter. To generate generator, we require some DC excitation. That purpose we require some exciter, DC compound generator. The exciter is provided to supply electrical energy to main field winding of generator. The amount of excitation required for a alternator depends upon speed, load and power factor. Main exciter is a capacity may be 0.5 to 3% of capacity of alternator, and sometimes we require to assist the main exciter, and that is pilot exciter. Its capacity 1.5 to 5% of the main exciter capacity. For example, if you are taking the 100 megawatts unit, we require nearly 500 kilowatts of compound generator for DC supply to main generator. To assist this main exciter, we require nearly 7.5 kilowatts of DC compound generator for excitation purpose of main exciters. This is very important for generators. Next, you can see the another exciter here. So, auxiliary station batteries. So, batteries are very essentials. Batteries are heart of the station and must be installed in a separate room. Independent source of supply is necessary for signaling, remote indications, remote controlling, etc. Generally, lead acid batteries are used in stations. Here is a doubt. We are the generating people, what is the necessity of storing this electrical energy? Suppose if any fault occurs in power station, then total system is collapsed. At that time, I want to know which breaker is on position, which isolator is off position. Then there is no power, there is no indications. At that time, I want to know, then I can take the supply from charger, that is the batteries. It must be kept in a separate room and maintained every day. Here is an example, you can see how the batteries in stations. These are the stations, so continuously charging, and we can take the supply whenever we require. In case of the high voltage switch gears, it requires independent sources. At that time, we can take this. To operate circuit breaker to close or open, we require the supply that will take from the charger or batteries. Now, so here is the, now we have seen different auxiliaries in power plants. In power plants, some of the auxiliaries in powerhouse, some of the auxiliaries in control room. What are the use? Already we have seen. So, here is another clip, you can see in TPS. So, you can see the control, how they are continuously monitoring total system. It is a load, they will indicate every hour indications, and here is the meters will shows the its active power, reactive powers, and total the position of all operators. You can see it. There is a continuous monitoring of each and every equipment. Then you can see it. If any modifications are required, then automatically they will instruct the operator as well as to they will do from the So, you can see here. This is the one example of control panel. Now, so second part is need for coordination of different power stations. What is the necessary? Power supply is highly capital investive, and therefore, it is desirable to utilize in optimum manner once generating facilities become available. Normally, the stations erected, then we have to utilize 100% because cost is in crores. Then that purpose we need to coordinate all power stations. Here you can see the what do you mean by. So, last class, in previous class we have seen different stations, its merits and demerits of different plants. You can see location of site, where it can be located, where abundant quantity of coal and water is available. It is somewhat nearer to load center, thereby reduces the transmission losses. And it can be HPS can be located where abundant quantity of water at sufficient height. It is far from load center, we require more transmission losses, cost is more, and away from thickly populated area is a further more. And initial cost, here is the initial cost, so 900 rupees per kilowatt. That means, suppose I want to erect 100 megawatt unit, I have to incur initial cost 9 crores for TPS 1 unit, and in case of 15 crores for 1 unit and 20 crores for 1 unit. So, 100 megawatts 1 unit. Running cost in case of the thermal power station very high, no cost for hydropower station, and the cost is between 2 stations. And in case of efficiency, the thermal power station maximum efficiency is the 30%, so nearly 25% only, and efficiency about 85% in case of HPS, and the efficiency in between